Okay, so talking about similar triangles, angle bisectors. So if I have triangles and the angles are being bisected here, note that even though this kind of looks like it comes straight down, it's not marked with a 90-degree angle, so I don't want to assume that it is. Your formula for this, if I call this AB and CD, the part of the base and the part of base here, the ratio that those form is the same as the ratio of the top side over the bottom side. Okay, that's one formula, and you saw a lot of that on your study guide. That is not to be confused with the altitude on hypotenuse. Altitude on hypotenuse comes from having a 90-degree angle, and then we're going to come straight down and it forms a 90-degree angle on the hypotenuse. So be careful when you're looking at your markings. This one has angles that are bisected, this one has 90-degree angles. I'm just going to label these sides like A, B, we'll call this entire length C. Okay, two things that you're going to be asked to find. One, if you're asked to find this guy right here, your x value, the formula is going to be x squared equals a times b. Okay, so we're going to go for the hypotenuse is part of the, the altitude is part of the hypotenuse multiplied by the other part of the hypotenuse. You do need both little pieces. If they want me to find the side length here, y squared is equal to a, we're going to take the little part, but then we're going to multiply it by the entire side length, c. If neither one of those work, you can't fit it into either of those formulas, then your third option is that within this triangle, you could look at one of your small triangles like this, and compare it to the large triangle here. They're going to be similar triangles because they both have 90-degree angles and they share this angle right here. And so you could compare the small triangle, maybe you compare like a short leg over the hypotenuse to the short leg over the hypotenuse of the very large triangle.